Hello, everyone. Welcome to this video on learning mathematics through concepts and examples. Today, we are going to look at some example problem on area between the curves. Let's get started with our first example. So here is the question. Find the area of the region bounded above by y equal to e to the x, bounded below by y equal to x, and bounded on side by x equal to 0 and x equal to 1. So first, we are going to sketch the diagram for this one. So we have y equal to e to the power of x. So that graph would be, let me try to draw that. Sketch that, I would say. So that is y equal to e to the power of x. I'm drawing it in the first quadrant only because I'm going from x equal to 0 to x equal to 1 only. So drawing on the first quadrant will be enough. Okay, so that is the graph above. Below by y equal to x. So y equal to x is a straight line going through origin. So it will be something like that. That is y equal to x. I'm not drawing it. I'm just sketching it. Okay. Bounded on the side, this side by x equal to 0. So x equal to 0 is this vertical line. That is x equal to 0 up to x equal to 1. So x equal to 1 may be somewhere there. So that line is x equal to 1. And we need to find the area enclosed there. So that means I can show the area like this. We want that area in red. Okay. So area bounded by the curve is the integration, in this case, from lower x value to upper x value. So x equal to 0 to x equal to 1, 0 up to 1. The upper function minus the lower function. Upper function is e to the power of x minus lower function is y equal to x. And we integrate with respect to x. Okay, let's integrate this. Integration of e to the power of x is e to the power x minus integration of x. X means x to the power 1, so we can use the power rule. Increase the power by 1, so it will be x to the 2, and divide by that new power. And we have to evaluate this between 0 and 1. Okay, so what do we do? If we use the fundamental theorem of calculus, we first plug in the upper limit, subtract, and then plug in the lower limit. So if we plug in upper limit, it is going to be, if I plug in 1, it will be e to the 1, which is e, then minus, I'm plugging in 1, so 1 is equal to 1 divided by 2, that's a half. We subtract and plug in the lower limit. If I plug in 0, e to the 0 is 1, then minus 0 is squared over 2, that is a 0, which is equal to e minus half, then minus 1, which is same as e minus 3 half. Okay, half minus 1 is negative 3 half. Negative half minus 1, negative 3 half. So our final answer is e minus 3 over 2. So that is the area of the region, which is shown here in red. Okay, that's our first example. Let's move on to second example. Here is the second example. We are asked to find the area of the region enclosed by the graph of the function f of x equal to 2 minus x squared and g of x equal to x squared. So first we are going to sketch the graph. You can see that f of x equal to 2 minus x squared is a downward facing parabola that is shifted 2 units up. So if we sketch the graph of that function, it will be something like that. I'm just sketching it. It's not a perfect graph. So this is f of x. F of x equal to 2 minus x squared. And then we have a parabola g of x equal to x squared. So we can also sketch that quickly like that. That is g of x equal to x squared. And we need to find the area of the region enclosed by those two. That is, we want to find this area, which is shown here in red. Okay, if I want to integrate with respect to x, I have to find the lower value of x here and then the upper value of x. That is where we have this intersection, okay? Where are these two graphs intersecting? So x equal to how much there? And x equal to how much there? In order to find the intersecting point, the x values, all you can do is you can equate these two functions. So if we equate x squared equal to 2 minus x squared, if you add x squared on both sides, you get 2x squared equal to 2, divide on both sides by 2, x squared equal to 1, and take the square root, x equal to plus or minus 1. So that means this is negative 1, and that is positive 1, right? That is a negative 1, and that is positive 1. So the lower boundary for the area is negative 1. Upper boundary for the area is positive 1. Now the area. Let's find the area. Area is the integration from lower x value up to upper x value. So negative 1 up to 1. Then it is the upper function minus the lower function. Upper function is 2 minus x squared. And the lower function we are subtracting minus x squared with respect to x. Notice that this function here is an even function. If you are integrating an even function from negative a up to a, in this case, negative 1 up to 1, what you can do is you can actually integrate from 0 up to 1 and double it. What I mean by that is you can do 2 times integration from 0 up to 1, 2 minus 2x squared dx. I combine those two. Okay, so I use the property of integration, the symmetric property of integration for even function. Instead of integrating from negative 1 to 1, you can just integrate from 0 up to 1 and double that. Okay, now let's integrate. So 2 we can keep as it is. And the integration of these 2 with respect to x is 2x, because the derivative of 2x is 2. And then minus 2 is a constant. Integration of x squared, if you use the power rule, increase the power by 1, so x cubed, and divide by the new power. And this must be evaluated between 0 and 1. Then we use the fundamental theorem of calculus, meaning we plug in 1, and then we subtract and plug in the lower limit 0. So if you plug in 1, it will be 2 times 2 multiplied to 1, that's a 2. Then minus 1 cubed is 1. 1 times 2/3 is 2/3. Then minus 2 multiplied 2. We are plugging in the lower limit now. 2 times 0 is 0. Minus 2/3 of 0 cubed, that is also 0. That means the entire second thing will be 0. And if you look at the first one, 2 minus 2/3 is 4/3. Multiplied to 2, that is a 8/3. 8 over 3. So the area that is shown in the red color in this graph is equal to 8/3. Okay, I hope you are enjoying so far. I'm going to solve one more problem so that you will be able to solve a problem like this one easily. Okay, here comes the third one. So we are asked to find the area of the region enclosed by the graph of the function y equal to x squared and y equal to 2x minus x squared. So the first function y equal to x squared is upward facing parabola. So that will be, if you are unsure about the shape of the graph, feel free to use graphing calculator and sketch it. And then the next one is y equal to 2x minus x squared. This is also the downward facing parabola. This is also a parabola, but downward facing parabola, which is shifted a little bit towards the right. So that means the graph will be something like this. Let me show you. Graph will be something like that. Remember, this is only the sketch. This is not the perfect graph. Y equal to 2x minus x squared. And we need to find the area of the region enclosed. That means this area will be here. That is the area. Now, in order to find the value of area, we need to know the lower boundary for the area and upper boundary for the area. I can see that the lower boundary here is x equal to 0. I can clearly see that. And this one, we need to find it. This is x equal to how much? We need to find it. So in order to find, what we do is, again, we equate these functions. So we can write like this, x squared equal to 2x minus x squared. If I subtract x squared on both sides, that will be 2x squared. And also if I subtract 2x on both sides, minus 2x equal to 0. Now we can factor this, factor 2x, and we have x minus 1 equal to 0. So this implies if we use the zero product property, either the first factor is 0 or the second factor is 0. If the first factor is 0, 2x equal to 0, then x is equal to 0, which we already have here, that is x equal to 0. And if x minus 1 equal to 0, then x equal to 1. So that is the second value that we are looking for. So in order to find this area, we need to integrate from x equal to 0 to x equal to 1. So we can say area equal to integration from 0 up to 1. Okay, integration from 0 up to 1. The upper function, which is here in green, 2x minus x squared, minus the lower function. Lower function, which is here in blue, is x squared. So I'm subtracting that and integrating with respect to x. So before I integrate, I'm going to combine the like terms. So that will be 2x minus 2x squared dx. Integration of 2x is x squared, because derivative of x squared is 2x, and then minus 2 is a constant. Integration of x squared will be x cubed over 3. And we have to evaluate this between 0 and 1. So we are going to use the fundamental theorem of calculus, meaning we are going to plug in the upper limit, subtract, and then plug in the lower limit. So if I plug in upper limit, 1 squared is 1, minus 2/3 times 1 cubed, that is 2/3. Subtract and plug in the lower limit. If you plug in 0, 0 squared is 0, minus 2/3 of 0 cubed, that is also 0. So everything in the second parenthesis is 0. And in the first parenthesis, we have 1 minus 2/3, which is 1/3. So meaning of that is the area that is shown in red here is 1/3. So this is how we can solve the problem involving area between two curves. I hope you find this video helpful. I'm going to end it here. Thank you so much for watching.